Okay, it's live.
It's live now?
Yeah.
Good morning, everyone. So we'll start in a couple of minutes. In the meanwhile, all the attendees are requested to check their audio settings. So while the webinar is on, you can type in your questions in your question box during the session, and the Universal Robots team will take it after the session. Fine. Good morning, everyone, again, and welcome you all for today's webinar. Hope you are enjoying the lockdown and taking good care of yourself. The COVID-19 pandemic crisis around the globe has made the production operation come to a halt, partly or fully. It's not just in India, it's all over the world. So such kind of situation demands production companies think and act differently, and also take advantage of the available technologies with us, like digitalization, robots, cobots. So in this webinar today, we'll discuss about the application and importance and various technicalities of cobots. Cobots is basically collaborative robots, and it can act as a co-worker for you. So considering today's situation, what we are going to do is we'll analyze the applications of cobots, how it can help you in various operations, repetitive tasks where you need the accuracy and quality. So with this, I will hand over to our speaker today, Mr. Karandeep Singh, who is the Senior Technical Support Specialist, South Asia, Universal Robots. And you can type in your questions in the questions box, and the Universal Robots team will answer it maybe during the session or after the session. So over to you, Karandeep.
Thank you, Mr. Shekhar. Let me just on my camera. Okay, so everyone can see me. Just a confirmation, you can type in the chat box if you can see me and my audio is okay. Okay, thank you. So I will not waste much of your time. We just start with the presentation. So during the course, you can type in your questions in the question box, and your team will answer them during the course. And after the session also, you can, in the same way, you can ask the questions, and I will answer it live. Also, during the session, we'll generate few polls also. So you can see the polls on the screen, and you can answer them during the course of the presentation. So let me start with my presentation. Okay. Good morning, everyone. Thank you for joining us today for this webinar on Automotive Factory of the Future, Achieving Manufacturing Excellence with Cobots. I'm Karandeep Singh. I'm the Senior Technical Specialist for South Asia region of Universal Robots. Today, I'll be taking you through the webinar to guide you on this unique technology so you can learn how to optimize your shop floor with Cobots. Webinar will be an introduction to the concept of collaborative robots, including what they are, how they are different from traditional robots, and how they can be used for many applications by virtually every industry. If you have any questions about any of the content we present today during the session, you can submit them directly into the chat window during the webinar session or email us after the session. I would like to start with a quick overview about our company Universal Robots. Company headquarters is located in Odense, Denmark, with global strength of over 680 employees. Our business model is through our distributor network, and we have 400 plus of them across the world. In South Asia, we have 11 distributors in India, Sri Lanka, and Bangladesh. Universal Robots has the highest cobot market share at 50%, with 42,000 cobot installed globally. The last few years, we have been seeing an increasing number of awards and lots of recognition. This is a list by Massachusetts Institute of Technology, which listed Universal Robots as the 25th smartest companies. You will notice it's on the same list with other innovative industry leaders like Tesla, Microsoft, and Google. Traditional industrial robots have been around for decades, but cobots are much newer technology, especially in India. Over the last few years, I'm sure many of you have been seen articles about the increasing demands for cobots and how a silent cobot revolution is brewing in India. But you may still be wondering, what is all this buzz about? This is a study done by Frost and Sullivan on the 50 major disruptive technologies that you need to know about. If you look under advanced manufacturing automation, you will see collaborative robots are features as a transformational technology. This is an Industry 4.0 wheel designed by McKinsey and Company, which shows the levers of Industry 4.0. Under labor, can see human robot collaboration or HRC as a major aspect of Industry 4.0. HRC is the foundation of the concepts of cobots, and I will now show you a video on how to set up a collaborative robot. Pay close attention and you may see quite a few features of the cobot, including this HRC. The cobot market has been growing with a compound annual growth of 50%, one of the highest growth rates in the automation industry in comparison to the industrial robot, which had a growth of just 5% in 2018. From the smallest companies to the largest multinational manufacturers, collaborative robots enable affordable, accessible automation to everyone. Cobots democratize automation by allowing manufacturers of all sizes to automate applications they may not have been able to originally, thanks to their flexibility, ease of use, and low footprint. To illustrate some of the reasons why cobots are becoming the automation solution of choice, have a look at this video.
When we say collaborative robot, you may be wondering what exactly we mean. Basically, cobots were created to share the same physical workspace as a human being because cobots facilitate the idea of human robot collaboration. The International Federation of Robotics defines four levels of collaboration with robots. First one is cell. This is the lowest level of collaboration where a traditional robot is fenced off from humans and operates in its own separate workspace. Second is coexistence. Coexistence is the next level where a robot is not fenced, but the human and robot both operate in their own dedicated workspace. In sequential collaboration, humans may share all or part of the workspace with a cobot, but they do not work on any job simultaneously. In the cooperation level, robots and humans work on the same part or machine at the same time, and both are in motion. Responsive collaboration. At the highest level of collaboration, the robot responds to the worker's motion in real time. Typically, traditional industrial robots can only work at the lowest level, while cobots allow for the highest level of truly collaborative applications. I'm
Okay, so before we move further, uh, I'm starting a poll now, which you will see on your screens, and you can answer it. Uh, uh, the poll, you have 30 seconds to answer, and the poll is regarding, do you already use robots on your shop floors or in your company? So I'm starting the poll now, and then you can answer it. Hope the poll is visible. It's on your screen. Okay, so right now I'm closing the poll, uh, and I'll show you the results of the poll on the screen. So you can see that the participants who have joined today uh, are like 56% of them are using robots, and 44% are not using robots. So maybe during the course, you will get to know how you can implement robots on your shop floor in different applications when we go onto the application slides. And I hope uh, you will get a good information from the session, and you can deploy more and more robots on the shop floors using automation. I'm closing the polls now, and we'll continue with the presentation.
I'm sure you saw some interesting features of the Cobot throughout the video. Now let us go into further detail of this product. As you may already know, these are traditional industrial robots. If you compare these to the cobots you saw in the video, you will notice a lot of differences. First and foremost, you will notice that industrial robots operate in safety cages. They are bulky and take up tons of space on the shop floor, so you can only deploy them if you have a lot of space. You can also see many more differences here. If we compare industrial robots, they are large, fixed equipment, typically requires safety cage, designed for high volume, high speed production, difficult to change to different process or product lines. On the other hand, collaborative robots, they are small and flexible to fit any shop floor or process, works at about the same speed as a human worker, fast setup, easy to use, and safe alongside workers. Even though we can see the difference between these two automation approaches, we are actually just seeing the tip of the iceberg. This slide shows the difference between industrial robots versus cobots in terms of their implementation cost. If we talk about industrial robots, the first foremost thing is the space requirements, which is 50% more considering any application. Other than the hardware cost of the equipment, there are several other costs related to implementation of industrial robots like end of arm tooling, safety scanners, light curtain, three-phase power, software upgrade cost, integration and programming if the process changes during operation, and majorly maintenance cost, which is quite huge for any end user to maintain the robot life. On the other hand, collaborative robots, which works on a single phase supply of 220 volts, which we generally use to run our mixer grinder or to charge our mobile phones, Cobot gives huge savings in terms of power consumption. Other related costs are only for hardware equipment and the end of arm tooling. For the Indian market, we calculated this as 6.5 lakhs of saving in 5 years of operation. This excludes the amount saved on space, which is an additional cost advantage. You will be wondering, what is this ISO TS 15066? Just as the ISO standard 10218-1 and -2 defines 4 different methods to achieve collaborative operation, the ISO/TS 15066 does the same. It just adds some more guidance and requirements to the specification. Safety rated monitored stop. A traditional robot which is used within a fence, a person can enter the workspace through an opening like door switch, light curtain, or safe camera solution which identifies the person is entering. When a person enters, the robot is paused. A safety rated stop function is used while the person goes in and do his job. example loading, unloading of parts. When the person leaves the workspace, the robot can resume automatic operation. Calling this method collaborative seems a bit odd, but the standard defines it as collaborative because electricity is maintained to robot motors while a person is present. Second feature is hand guiding. This is hand guiding as a part of a robot operation, performing the work, not the teaching or the programming. This should not be confused with hand guided the programming of cobots. This method used in a traditional robot inside a fence when a person is entering the cell periodically as a part of normal operation, that is to adjust a pose or to screw some screws in. When he enters, the traditional robots changes from non-collaborative to some collaborative mode. Example, maximum speed could be 100 mm per second and adjustment moment plus minus 50 mm. The car industries has used this method for several years to place chairs inside cars and to hold bumpers while they are screwing in place. Third is speed and separation monitoring. This method is similar to safety rated monitored stop, but instead of pausing the robot, the speed of the robot is decreased depending on the distance between the robot and the operator. One way to do this is to have a area scanner to determine the distance in a safe manner. The other way is to use a safe capacitive sensing skin onto the robot. The skin can sense that a person is close to the robot and thereby stop before it touches the person. The last one is the power and force limiting. This method applies to robots specifically designed for collaborative operation like the UR robots. The robots are sensitive to feel resistance in the movement and thereby stop before it causes any injury. For slow speed, force and pressure is relevant, and for higher speeds, mass, inertia, orientation, momentum and energy is more relevant. This is the method which is typically used in UR robots. By default, UR is giving all the 4 features in the software. Other than ISO TS 15066 standard, UR Cobots has patented safety system with adjustable functions which allow work at ease in a collaborative operation. Functions like joint position, joint speed, TCP position, tool orientation, force, momentum and power. From the product line, Universal Robot offer 2 series, CB3 and E series. CB3 has 3 models, whereas E series has 4 models with different payload and reach. The models are UR3/UR3E, UR5, UR5E, UR10, UR10E and UR16E. Our E series is the latest range of cobots. Compared to our previous generation of cobots, it has improved sensitivity with built-in FT sensor for process applications like polishing, grinding, deburring, etc. It's 4 times faster than our previous generation series with category 3 PLD safety, having 17 built-in safety functions with stopping time and stopping distance functionality, higher flexibility in the wrist 2 joints to avoid any pinching during motion. All the software updates are possible with one single file with easy programming flow given on the new capacitive widescreen Teach Pennant. Universal Robots has set the standard for collaborative robots with fast setup, easy programming, collaborative safety, and flexible redeployments. Let's see short videos on each to better understand one by one. You already saw the Cobot setup in the video I showed in the beginning, so I won't play this again. But our Cobot comes in 2 boxes. One contains the robot arm and the other one has the control box. It takes approx 1 hour to unpack the Cobot, mount it and program for a simple task. As you can see in the picture, how UR Cobots can be easily redeployed in other production environment without changing the layout on the shop floors.
This is a collaborative robot, also called Cobot. It's a 6-axis robot, can be used for multiple applications. Here we have the Teach Pennant. On the T-pin we also have a free drag button which we can hold in, and then we can take the robot and move it into a certain position. We can also in our program tree take which function we would like and put it into our program. I have now made a small pick and place application that I will show you.
One of the main advantages of Cobots is the safety. This Cobot has 17 built-in safety functions. We have, among the 17 safety functions, force limiting, which means that when the Cobot is in action and I accidentally step in the way of it, it stops. And I can just start it again from that point in the program. Another feature is the safety planes, which can be set up to reduce the workspace of the robot so it can't collide with humans or equipment.
Mankind's journey in manufacturing has gone through various industrial revolutions. While it is most widely agreed that humans are now in the fourth generation of industry or Industry 4.0, many people, including our own company and founder, believe that we are actually on the fifth industrial revolution where humans and robots are working together better and faster, enabling higher value creations. Just to give you an example of the Industry 5.0 that is enabled by collaborative technology, have a look at this video of BMW plant in Dingolfing, Germany. Here, the cobots are being used for the gap inspection of doors on BMW cars to ensure the highest standards of consistency and quality that you would expect from a BMW. However, you will see the cobots are not alone. There are also humans walking between the cobots to check that everything is running smoothly. Here, cobots and humans are working hand in hand, side by side. The intellect of humans is indeed paired with the consistency and precision of the cobots, ensuring that both do what they do best to churn out perfect quality. By now, I hope you have noticed that instead of a big bulky machine, our cobot is like a tool that can be used to give a competitive advantage to manufacturers. Now let's get into the possible applications of collaborative robots. In order to help identify the right application, one must carefully look into where are the current automation gaps are. So before we start the applications videos, I would like to start the second poll and we'll answer a few of the questions which are coming in. So, uh, so I'm starting the second poll now. I hope my screen is visible. And again, you will get another 30 seconds to answer. And the poll is regarding what application are you thinking of automating with cobots, and there are few options where you can select and answer the poll. So I'm starting the poll now, which will be live on your screen.
Okay, thank you for your answers. I'm closing the poll now and we'll show the result on the screens. So the question was, what application are you thinking of automating with cobots? And we have got the results with 36% are thinking to automate in screw driving or assembly application, which is quite a good number. Injection molding is 7%, machine tending 15%, which is again quite good. Packaging or palletizing, like kind of palletizing and dispensing, and 17% is in quality inspection. So the videos which are coming in the presentation now will solve most of your queries how cobots can be used in such applications, and I hope you will get answers to that. And so before going to the videos, let me see some questions and I'll try to answer them, and remaining will answer in the at the end of the session. Okay, so we got questions from Mr. Tarun Prakash. He is saying, is your team directly take turnkey projects for implementation of cobots? He's from MSIL Gurgaon and he's looking for installation of Cobot. So we have partners, distributor partners who do the applications and user applications, but you can send your query to our email address avin@universal-robots.com, and will and also share your application details. We'll answer them and we'll connect you with the right partner who can do the application. Mr. Balamurgam is asking whether all servo motors used in each axis of same model, so that software maintenance cost will be less. So basically, if you consider a middle range cobot, which is UR5, then the three axes are similar and the top three axes are similar. So in a UR5, you only need two joints because the base, shoulder, and elbow is of same size, meaning the mechanical and the electrical components are similar. And on the wrist, which is wrist 1, wrist 2, and wrist 3, is of same size, so you need only one joint of that. So if you consider the robot arm, then you only need two joints to maintain the spare. Another question from Mr. Balamurgan, will you provide end of arm tooling also? So end of arm tooling is kind of customized, which is designed by our distributors based on the application. But we also have standard grippers available on our UR Plus website, and that will come later in the presentation, and you will get idea what kind of tools are available. Mr. Khan is asking what is the starting price of cobots. So the starting price is between, if you consider the third generation, which is CB3, then the starting price is between 15 lakhs to 22 lakhs. And for the latest generation E-Series, it's 18 to 25. Mr. Jangra is asking tentative cost of 12 kg payload cobot. So we don't have a 12 kg payload, but we have a 16 kg payload. And so the range is 3 kg, 5 kg, 10 kg, and 16 kg. And 16 kg is with E-Series, which is the 5th generation. And Tentative cost could be around 25 to 28. This is just a budget number. Actual cost will come from the distributor. So Mr. Dinesh is asking how easy to program. So it's very easy. Like you can drag the robot with your hand, and automatically the paths will be saved during the motion. We have an online academy which will come later in the academy, where you can learn how you can program the robot, and you can teach for different applications. Mr. Edwin Marcel is asking, have you mentioned cobots have skin sensors? Would the sensor work based on servo motor torque or any other special sensor based? So particularly in UR cobots, there are no skin sensors available. Like it's available from third-party companies, but it's just an add-on to the arm to give more safety if you want, based on the application. But basically, UR robot works on power and force limiting factors. So meaning if the robot is running at high speed or at a low speed, the feedback of power and force, when any obstruction will come during the motion, the joint will stop automatically, or will drop the current or the power from the robot. So it stops and give productive stop message onto the screen. Mr. Polkar is asking, can it possible to use cobot in special processes like heat treatment, operating, induction hardening? Yes, it's possible. A short video is available on our website and also on YouTube. You can post that video. If you're interested in the application, you can write to us at avin@universal-robots.com, and we'll help you provide the solution. Mr. Mukesh is asking cobot programming software, how to get. So we have a UR simulator software which is available online and is free of cost. You can download from the website. If you're using a Windows laptop, then you need a virtual machine to run the simulator, and you can learn the programming. And also we have Academy, which is online academy free of cost, which is a 2-hour course, and you can create your sign up and as a sign-in, and you can learn about programming the cobots. If you need like a full course on cobot programming, then we are offering from our Bangalore, Noida, and Pune office. So you can register with us, and we can give you the much more training on the cobots after this lockdown period is over. So Mr. Anil Jan is saying there are a couple other areas where we can implement this, but your system don't allow. My request to Mr. Jan is, can you, if you can share what areas you have identified, and you can mail us, and then we can help you provide a better solution where cobots can be implemented. Mr. Ramachandran is asking, planning to use in robotic soldering in electronic industry, is it possible? Yes, we have a solution where you can mount a soldering gun onto the robot, and you can do the soldering of electronic components. If you want to see videos, you can go to our YouTube channel or on our website, and you can see these. You can see those videos. Mr. Balamurgam is asking, what is a maximum reach that can be used in injection molding? So as I told, we have 4 different models. The reach is for 3 kg robot, we have 500 mm. For 5 kg, it's 850. For 10 kg, it's 1.3 meters, and for 16 kg is 900 mm. So answer your question, the maximum reach what you can get is 1.3 meters with UR10 robot, and mostly for injection molding machines, we use UR10 robot for those applications. Mr. Pradeep is asking expected life of such a cobot, please. The life of the whole arm is 35,000 hours, which depends on the payload and how you run the robot, and speed and acceleration factors. But as a whole system, 35,000 is what is the life of the whole arm, depending on how you use it. Mr. Malik is asking, have you done any cobot installation in rubber molding? Yes, examples are available on YouTube. Not in India, but globally, there are examples where robot is being used for rubber molding machines. And Mr. Tarun is asking, maximum payload model is 16 kg in UR16 series. Yes, the maximum payload is UR16, which is under E series. So the full terminology is UR16E, which comes with the fifth generation series. Mr. Savanan is asking, in painting, we have manual air blow, whether it can be automated. Yes, it is possible. We are doing a powder coating application in Pune. We are doing powder coating application with paint and air blow in Gurgaon region. So that application is possible. You can share your application to email ID avin@universal-robots.com, and we'll help you with the solution. Mr. Madhav is asking, what is the maximum payload we can use? Maximum payload is 16 kilograms, which includes the gripper and the component. So if you're taking UR10, so UR10 meaning the gripper weight and the component weight. Mr. Sandeep is asking, can you please explain about deburring process? So deburring, so you can do deburring by two methods. One is you can hold the component onto the robot or the tool with the robot, and you can create a remote TCP, which is only available in E series. So using remote TCP feature or the functionality, you can do deburring easily with collaborative robots. There is a video available on YouTube and also on our website, where a robot is handling a payload from 4 kilograms to 14 kilograms and doing deburring of the components. Mr. Manish Shankar is asking minimum maximum payload of Cobot. So minimum payload is 3 kg and maximum is 16 kilograms. Mr. Tarun is asking anything above 16 kg. As of now, no, sir, because if you see a 16 kg robot, then the overall mass of the system is around 33 kilograms. So basically, the cobots are made because of the safety considered, because it's always working alongside with the humans. So if we increase the payload, then the overall the mass of the arm will go high, which will increase the safety hazard. So right now we are restricted to 16 kilograms, but future development as of now, I cannot say. Maybe something is there, but as of now it's only 16 kilograms what we are offering. Mr. Sunil is asking maximum payload is 16 kilograms. Mr. Balagmurgam is asking for painting application, it is supposed to be flame proof. So for painting, we can only use in water-based solvent application. You cannot use in thinner-based application, as we don't have ATEX certificate for the cobots. Mr. Pradeep is saying, I'm from Minda Industries. We are making automotive lightning components, and can we support in 10 lakhs, or you can support, sir? You can share your inquiry, and we'll help you with the application. It mostly how you do the application. Cost is one factor, but we have to see how the application can be done. You can send your inquiry to avin@universal-robots.com, and we'll help you. Mr. Karthikeyan is asking what is a calibration method and how to calibrate. So the joints, the robot arm is calibrated using dual arm calibration, which is done in our headquarters. And if you change the joint, if it fails due to any reason, then you can calibrate in the software, which is like a 5 minutes job. Mr. Ravinder is asking, can you send comparison detail? Yes, we will send you the comparison detail. Please share your email ID and we can send you the details. Mr. Pankaj is asking, have you done any project on insert molding and visual inspection? Yes, there are projects available and applications available for insertion of the components. Mr. Pankaj is saying, are you dealing with AGVs? So as you are, we only make collaborative arms, but our sister company MIR makes AGVs, and you can use those AGVs for material movement. Mr. Gunasekharan is asking, hi sir, both robots and grippers are from UR, or are you getting it from other vendors? And what is the MOC of Cobot? So the grippers are customized. It's not from UR. You can use a customized gripper, or you can use grippers from Schmalz or Festo, Schunk. There is no restrictions on grippers. And you can also make your customized gripper based on application. Mr. Muthu Raman is asking, is it possible to identify spot repair areas on painted parts and do not touch up process? Yes, it's possible using a vision system. We can see the repair areas, and we can do a process to solve those also. Okay, Mr. Ravinder is asking, can you send comparison sheet between industrial robot and universal robot? Yes, sir. Please share your email ID, and we'll send you the comparison sheet. Okay. Mr. Balamurgam is asking whether cobots can be used for secondary operation like gate cutting, runner cutting, and plastic components. Yes, it's possible. We have applications like that where robot is used for cutting. So basically, we mount a knife outside the molding machine, and if robot is handling the part, so we'll take the part over there and then activate the knife to cut the part. So it's possible. Okay, Mr. Somik Ghosh is asking, can we use Cobot in priming application? Also, how can we program the Cobots for multiple models of varied geometry? So yes, you can use for primer applications. The first video, what I'll show you right now, is based on dispensing only on a windshield glass, and you can use it. You can store various models on the Cobot. It's possible. Okay, Mr. Karthikeyan is asking, is it possible to use Cobot in continuous flow assembly slot conveyor? Yes, it's possible. In the software, we are giving conveyor tracking as a standard feature where you can connect external encoder and you can do the conveyor tracking with Cobots. So, rest of the question I'll ask in the later session. Let me continue with the presentation now, and you can still post in the questions tab, or you can answer it in the chat window, and my team is available. My tech team is available, and they can answer your questions in the chat window. And let me continue with my presentation.
This application is for glue dispensing on windshield glass for cars. Here, a UR10 Cobot is inverted mounted, which shows flexibility of UR Cobots to be mounted in any desired position or angle. You notice that humans are also working alongside the Cobot on the assembly line without any cages. The 360 rotation on each joint gives more flexibility in terms of programming the robot. This example is for screwdriving application, which is nowadays in demand by industry who are using collaborative robots, as screwdriving is an essential task that requires precision and also presents a high ergonomic risk to worker due to the repetitive movements and pressure in the hands. I'm sure you have heard of Group PSA, which is French automobile manufacturer, which includes huge car brands such as Opel, Citroën and Peugeot. They are using two UR10 robots for screwdriving in their assembly lines suspended upside down. The robot has to screw on the two sides of the vehicles without bothering the operators who simultaneously work at other assembly operations. The Cobot is attached to a post or a fixture which goes under the vehicle in production. Two operators pull down the post and block it on both sides. Then UR10 follows a well-defined cycle. It inserts 3 screws on the right side and 3 on the left. It refolds itself at the end of the operation, and 2 light bulbs light up to indicate if the work is correctly done. After that, it swells itself back into the operating position for another cycle before the arrival of the following car. A task which seems easy at first sight is an essential step in the conception of the vehicle, which requires a perfect, flawless execution. In fact, Group PSA realized this new application was unique and even decided to patent the entire application, integrating the UR10 robot on a national and international scale. You will notice that a lot of flexibility is required for this kind of application. A traditional industrial robot would not be able to operate upside down or without cages with people on the shop floor and fit so easily under the car body in places that are hard to reach. Only a collaborative robot can be used.
At the plant in Hamilton, Ohio, 9 universal robots now enhance production, handling machine tending, assembly, and inspection tasks.
There was what we call this revolution, and I felt that we're in the right time with the right opportunity to be part of it. Collaborative robots was always the most attractive for us to go get more business, expand your facility without having to rely on finding resources constantly in such a warm market. And I said, there's no fence on wheels, and that for me was when things really clicked. We decided to partnership with one source, one type of cobot, and that's when we picked our first cobot with UR. We investigated a few other options. The UR had the most advanced solution for more precise pick and place, repetitive, easy to maintain, easy to program, and I think the most important was the speed. It has been fantastic. Today we have 9+ projects implemented and another list of another 40 to be implemented. Our president and CEO came with the idea of naming us the name of the presidents of US. And so we started with the very first one, George Washington, and so far we have had other 10 presidents already in our facility. So this is a very important facility.
Once we got the first one done, it really spread quickly. We started to notice different applications all around the plant. The one has the inner tube, it forms it, it punches a hole in it, and then places it on the transfer fixture. The second robot then picks that up, loads it into the marriage station where it grabs the outer tube and marries them together, and then it forms them one more time and sticks it on the exit chute.
The UR10s also perform cleaning operations on the ends of the tubes, prepping them for welding. In the final assembly, the cobots handle post-crimp fill and inspection.
Before we would check 2 parts every hour to make sure that we were still where we thought we were, but now we have 100% inspection.
There are different sort of projects. There are projects that have longer ROIs and projects that have short ROI. Collaborative robots that we see as a quicker return of investment. Right now we are attacking the ROIs that are between 10 and 14 months.
For testing new applications, we have both the demo unit robots. In addition to that, we actually use RoboDK, and that helps to actually see the robot going through its workflow, figure out if our cycle time is going to be accurate enough that it's worth prototyping and getting it out there. And then whenever we deliver it, it's almost ready to go.
The goal was not just deploying Industry 4.0 and cobots in this plant, it was literally to enhance the experience of our employees and to make this place a good place to work.
Operators are at the forefront of all the building that goes on in this company, so asking them, hey, where can we help you to improve the process, to improve the quality of this product, we find that very useful. No operator will lose their job due to collaborative robot being implemented.
This application is using UR10 cobot equipped with 3 tools, 1 screwdriver, gluing gun and vision camera, performing glue dispensing and nut running on Mahindra car engines, and showing how Mahindra is using cobots in their factory of the future.
A lot of disruptions are happening in auto industry. To survive, we need to do continuous improvement, do better than what we were doing yesterday. I have been working here last 25 years. Our focus is mainly on the quality piece. Whichever is critical to quality, we want to automate it. One of our team member gave a thought, can we go for a Cobo, collaborative robo? We can implement online and it can work with our associates. It's not only the sealant application or the tightening application. There is a camera which checks the quality and it gets recorded. We are able to real-time monitor the Cobo performance also. It is very safe, easy to teach, very flexible. When Cobo is working with them, people are loving it.
रोबोट बरोबर काम करताना आम्हाला एकतर वेगळं फिलिंग येतं कारण आतापर्यंत आम्ही ऑपरेटरशी कंपॅरिझन करत होतो आता असं आहे का आम्ही मशीनशी कंपॅरिझन करतोय मशीनचं काम ॲक्युरेसीमध्ये असतं 100% क्वालिटी असते त्या क्वालिटीतच आम्ही काम करतो आणि त्याच्या स्पीडने आम्ही काम करतो त्याचा एक वेगळा आनंद आम्हाला मिळतो
Going forward, we want to explore how we can implement Cobot more and more. Future is enormous. We all have to continuously improve with respect to what we were doing yesterday.
This application is with 6 UR10 Cobots at Ford, Germany, where they're being used for polishing or sanding application for whole car body, assuring finishing of the vehicles before the car body goes for painting operations.
A car is in pristine condition when it rolls off the production line. But how is that sleek, smooth factory finish achieved? At Ford, it's a team effort. Our engineers work alongside specially trained robots to finely sand the contours of every Ford Fiesta. The collaborative robots, or Cobots, complete a choreographed movement to smooth the entire Fiesta body in just 35 seconds. The same Cobots are used to polish high-performance audio equipment. While one Cobot can handle the flat surface of a speaker, 6 are required to sand a vehicle. Achieving this precise choreography required hundreds of hours of programming to ensure the correct pressure and movements are applied to the surfaces. The Cobots also vacuum any dust created. This unique team ensures every Ford Fiesta has a perfect finish.
This application is for inspection, where 2 UR5 Cobots are equipped with Cognex Vision camera and is performing quality inspection of car bumpers before it goes for final assembly on the cars. This application is for labeling, where 2 UR10 being used for placing car name logos on the assembly line, working alongside with humans. The cobots are synchronized with assembly conveyor and places the logos based on the camera feedback and checks the placement again using camera feedback. The C8 plant has 20 collaborative robots which support workers along the line.
At the beginning, the robot starts referencing. This involves detecting the seat adjustment in the longitudinal direction of the seat. The test scope of the switch test and the axle test includes the lordosis test, the force-controlled switch interaction and the axle adjustment. Axle adjustment includes seat tilt adjustment, seat height adjustment, seat longitudinal adjustment, and backrest tilt adjustment. The body sense test, also known as seat occupancy detection, includes picking up the body sense tool from the parking position, placing it precisely with adjustable pressure force, and returning the body sense tool to the parking position. The belt buckle test includes the detection of the presence and removal of the belt buckle tool from the parking position, the detection of the belt buckle adjustment in the seat longitudinal direction, and the guidance of the belt buckle into the defined contacting position. The contacting and decontacting of the belt buckle are also part of the test. Finally, the belt buckle tool is placed in the parking position.
Here are some of the larger Indian customers we have. You will notice they are all from completely different industries and exploring completely different application using UR Cobots. But as you know by now, the mission of Universal Robot is to make automation easy and accessible for small companies too. In this slide, you can see some of our SME and even MSMEs customers in India who have been able to use this revolutionary technologies with ease on the shop floors. Some of these companies have only a manpower of 10 people and very small shop floors with some just in sheds. However, even they have deployed and benefit from Cobots. One thing you can notice is the human-robot collaboration in every photo. In fact, most of these Cobot operators have not been educated beyond 10 standard and they are now all trained in Cobot programming. Now we will get into our Universal Robot Plus ecosystem. Basically, the UR Plus ecosystem is a platform of third-party created products that are tested and certified to work with our Cobots. The idea is to make automation even more easier and time-saving so you can plug and play and produce instantly. Recently, we launched UR Plus certified application kits where, for example, if anyone is interested in polishing application, then they can buy this application kit as a plug and play solution with UR Cobots. Similarly, we certified components and accessories to build the applications. For info, you can visit our website for more details. The three key benefits of UR Plus ecosystem to our customers is less investigation and shortened decision-making time, avoid reinventing the wheel, which will make deployments of projects faster, and all the products are tested and certified by Universal Robots. Application Builder is a platform where end user can see a simulation of applications like machine tending, pick and place, palletizing, screw driving using options by selecting robot type, tool setup, how in-feed and output will be arranged, and what interface you are looking at. So when you select everything as shown in the last slide and click on the run simulation, the video will run as shown. User can also download packages which includes design, program and interfacing tips by filling a short form on the web page. We keep saying that our cobots are easy to program, but just to give everyone the chance to see it for themselves, we have Universal Robots Academy. It's a free online platform where anyone can learn to program our cobots in just a few hours. Universal Robots Academy contains 9 easy modules that are built to deliver hands-on learning via interactive simulations.
fill your automation gaps. Once you identify where your automation gaps are, you can identify the right application to optimize your manufacturing process. The COVID-19 situation, which we are facing right now, is having strong repercussions everywhere, including the manufacturing world, where congested shop floors can make it hard to follow social distancing. Cobots, however, are an ideal solution as they work alongside workers on the shop floor and ensure quality and efficiency is optimized, all while making sure that people maintain distance as per required safety regulations. It is important to adapt quickly as possible to stay afloat, and cobots enable manufacturers of all sizes to become future ready. Now, I would be happy to take questions at this time. Please do write to me and I will answer them. Okay, so that was the end of my presentation. We have few questions still coming in, so we'll answer those. Mr. Karthikeyan is asking what is accuracy level. So I think my team has already answered, but accuracy level for third generation is zero point 0.1 mm, which is 100 microns, and for fifth generation for UR3E and 5E is 30 microns, and for UR10E and 16E is 50 microns. The response time for uh, the third generation series, when you press play button on the T panel, then it's 8 millisecond it takes to do. But E series is quite like it's 4 times faster than the third generation, so it's running on 500 hertz of frequency, whereas CB3 is running on 125 hertz of frequency. Mr. Davis is asking, is it possible to share the end grip design or supplier for painted parts polishing? Uh, sub, the design of grippers are actually based on the applications. So it's better like you can share your applications and we can look into it, and we'll assign a distributor who can design a better gripper for your application. You can write to us on avin@universal-robots.com. Mr. Sachin is asking, can the robot reach be customized for the difficult to reach areas? No, you cannot customize the reach. The payload and reach are correlated, so you cannot customize, but you can customize the tool. So basically, tool can go to a different areas, restricted areas, rather than the robot. So that you can control. Mr. Muthuraman is asking, how do you help in improving the ergonomics of loading and unloading parts of 14 kgs on moving over at conveyors of 15-second cycle time? So 14 kg, it's like handling of the part. So if you want to handle 14 kg, then you can use UR16E, which is the highest payload model what we have now. The 15-second cycle time is like, so if it is not possible with one robot, we can have more robots on the line to manage that cycle time. But like in other industries where cycle time is not matched, then they try to optimize. So basically they try to optimize not the 100% automation, but by doing partial automation, which is 80% automation and 20% manual. So your main ergonomic issue is to handle 14 kilograms. If that can be handled by robot, and the other part can be handled manually, then I think that is the best scenario where Cobot can be used. Okay, we got one question from Mr. Vijay. How correct pressure is applied while polishing? Whether you need the other tool for that. If you consider the CB3, then we have a force feedback function which works on plus minus 10 Newton meter of feedback. And in the E series contains internal force torque sensor, which is which will give you resolution in 0.02 Newton meter resolution, and you can use that force for applying during polishing application. Okay, whether all visual inspection can be done by Cobot as like by inspector? Yes, you can attach a camera with the Cobot, and based on the inspection points, the robot will move and inspect all the points on the component. It is possible, as I shown you the bumper inspection video. So there are like maybe around 40-50 points which both robots are doing the inspection, and it's possible. Okay. We still have 10-15 minutes. Like I'll take another 10 minutes, then I'll switch over to Mr. Shaker, where he can give the closing remarks. And if any other questions you have, you can still post it in the questions tab and or in the chat window, and I'll answer them. Mr. Ravi Shankar is asking, can one robo be used for join two parts and also screw driving? Yes, it is possible. So basically you can attach, like I show you the Mahindra video, where they are using a screw driving tool, a camera, and a dispensing gun. So first the camera clicks the picture of the engine to see the orientation and location. Based on the feedback from camera, it does the gluing and dispensing, and then the engine transfer to the next station, where operator loads the top cover and with the screws, and then the Cobot do the screw driving. So yes, you can attach 2 or 3 tools, and based on the requirement of the tool, we can change the TCP, which is tool center point, and then we can do the application. Mr. Karthikeyan is asking, do you have any solution to handle the load of more than 16 kg with Cobot? As of now, it's only 16 kilograms, which what we can handle with Cobot, and it's including the gripper and the component. Okay, Mr. Vijay is asking, is there any international safety body which approves that this Cobot can be used without cage? Yes, sir. A technical specification 15066 is available, which is only based on collaborative robots. You can see that whole guidelines on ISO website, and you can learn how Cobots can be used without the cage. Mr. Polkar is asking, can Cobots work with multiple arms? Yes, it's possible. So you can connect both arms using Ethernet connection or a Modbus connection, and even with the other robots also, you can do using Ethernet, TCP/IP, or Profinet communication. But multiple arms of same category or different category is possible. Okay, Mr. Subramaniam is asking, what is your standard AMC period? What is the service cost for calibration of robot beyond AMC period? So basically, we don't have a AMC format. What we sell is a service 360 model. So it's kind of a extension of warranty. So standard system comes with 15 months warranty, and then you can extend the warranty for next 3 years in one go, or you can buy every year. General AMC could be like, if you want to clean the filter fan, your own maintenance team can clean filter fan or clean the arm body and check the bolts, mounting bolts, which is kind of general, and there is no charge for it. Your own team can do that. Service cost for calibration of robots. So as of now, there is no service cost related to calibration, and our calibration is not like you need to pay for that. You can also do it by yourself. The calibration, we can teach you how to do that, and But if you're looking the AMC for like whole system, if you want whole system, then my distributor can give you a AMC for the whole system, which will include the cost of the robot, which is Service 360, and plus the other equipment which is coming along with the system. Mr. Karthi is asking price bandwidth for 3 kg payload for soldering application. 3 kg range is between 14 to 15 lakhs. This is just the budget number. Actual pricing will come from the distributor. On the tooling part, since the tool is like a third-party tool, we don't have any pricing, but we can give you links on where you can contact and get the details on pricing. Just share your application at email ID avin@universal-robots.com, and we'll send you the information. Okay. Will Cobot cost is less compared to robot if we consider the safety infra that need to be added? Yes, if like I show you the implementation cost implementation slide, where we have seen there are a lot of costs related, even though the hardware cost is less, but if you consider safety scanner, safety guarding, light curtains, programming, and maintenance, the implementation cost of industrial robot is higher, and as comparison to collaborative robot, because they don't use any of the safety guarding around the system. If your safety team requires that, still I want to use safety equipments, then it's the company decision. But you are Cobots, 80% of our application run without cages, and the standard supports that you can run without the cage. Mr. Subramani is asking, do you have special price for academic requirements? Yes, you can see the reply from Adya. She's from marketing, and yes, the educational pricing is there. You can write on avin@universal-robots.com. Okay. Okay, you still have another 4 minutes before I switch to Mr. Shekhar. So Mr. Sachin is asking, do you have special consideration and scheme for engineering institutions if they want to establish robotic lab in their campuses? So our distributors have made educational kits for engineering colleges or universities. We have one example available from PSG College in Coimbatore. The case story is available on our website and also on YouTube, and how they are using cobots in their curriculum to teach students about this new technology, and how they are using cobots in day-to-day in learning and doing applications with collaborative robots. So you can see that video on YouTube or on our website, and you can get a fair idea how cobots can help in educational institutes. So Mr. Vinod is asking, as the cobot gets old, the speed and accuracy will impact. We never seen that. It's that the speed and accuracy will impact. There is no issue with that. If some joint is creating some noise or it's failed, then you can put that particular joint and you can calibrate that particular joint, and then you will again get the same speed and accuracy. Okay, so let me switch to Mr. Shekhar now for the closing comments. And if you have any questions, you can still post it on our email address, avin@universal-robots.com. Mr. Shekhar, over to you.
Hello? Hello, can you hear me? Thank you, Karan. It was interesting and quite informative presentation, the way you gave the application details of Cobots and how easy it is to use with it, including the programming. I hope I'm audible. So I specifically would like to mention one video of Mahindra Rise, where the operator was happily mentioning that his working with the Cobots, saying it was fun to work with the Cobots, and now he can compare his performance with the Cobots' performance in terms of accuracy and speed. That was interesting. So, friends, this is the time where you can get the information of the technologies, various technologies available with you in terms of the cobots, robots, digitalization, with various shop floor softwares. So when the our lockdown gets over and we come out of this critical phase of COVID-19, we will resume the production and we'll have more orders from the market. And in that time, then you will be able to resume your production with the real-time operation. And with this, I conclude the program. So thanks all of you for attending. Thanks, Mr. Karandeep Singh, and thanks to Universal Robots for this opportunity. And stay safe and stay healthy. Take care of yourself. Okay, thank you.
Okay, thank you, Mr. Shekhar, for the closing remarks. Just a second, I'll on my camera. And okay, you can see me now. So one last question came. I would like to know from Mr. Muthuraman, what is the weight of the cobot, which I replied. So UR3 weighs 11 kilograms, UR5 weighs 18 kilograms, UR10 is around 28.9, and UR10E and 16E is 33 kilograms. Mr. Okay, one last question. Will spare part get obsolete within the life of 35,000 running hours? This is a big problem when technological advancement happens. No, sir. So basically, our stand is, if we stop the production of a particular model from that year until next 8 years, the supply of spare parts will be there. As of now, we are supporting both CB3 and E series. So in India and globally. So there is no spare part stoppages, and 35,000 running hours is only for the robot. And if something fails, you can just change that particular joint or part, and again you will get the same life of the robot. Okay, thank you, everyone. So here I close the webinar, and if you still have many questions, I know, but you can contact us on avin@universal-robots.com, and we'll come back to you. We'll answer your queries, and we can help you automate using cobots on your shop floors. Thank you very much, and stay safe, stay healthy.